Okay, so up here we have got two more identities that we need to know. Sometimes we will need to use them, sometimes we will not whenever we see a 2 theta. So sine of 2 theta is 2 sine theta cosine theta. And cosine of 2 theta is cosine squared theta minus sine squared theta. I could have given these to you in with our identities and stuff as well, but I did not. I chose not to do that. But there are some trig equations we're going to have to solve that we need to know this here. So these are facts just like sine squared plus cosine squared equals 1. So we will sometimes need to use those. So these, along with those that you had the quiz on, these need to be memorized. Okay, so you'll need those for the test. There won't be tons of them, but there'll be probably at least 1 or 2. So the problems that we're looking at today, most of them, actually not most of them, several of them though have a sine 2x or a cosine 2x here. So we need to know how to deal with that. And sometimes it will be helpful for us to use these identities here. And at other times, it is not helpful for us to do that. So, this first example is not going to be helpful for us to use the 2 sine theta cosine theta in this case. Because I can just solve this for the sine. So, I will have sine of 2x equals 1. If I just move that 1 over to the other side. So, I'm just adding that 1 there. Okay, and I should have set it up already. Let me put my unit circle over here. Okay, so we've got our unit circle here. So what we're going to do here is, instead of sine of x equals 1, I've got sine of 2x equals 1. But it's still sine of something equals 1. So I need to think about, where does sine equal 1? What we're doing is we're doing sine inverse of both sides, which gets rid of the sine. You don't have to write that. But when I'm doing sine inverse of 1, that means, where does sine equal 1? Okay, so, sorry, make sure this is not daycare. Oh no, Amber Alert, yeah, sorry. All right, so we're thinking about, where does sine equal 1? Sine's our y coordinate. Where on the unit circle, specifically principal values, does sine equal 1? Pi over 2. All right. So pi over 2 is sine inverse of 1. So, but it's not x equals pi over 2. We got to say 2x equals pi over 2. And then, so if I want to solve this for x, I've got to divide both sides by 2. That's 2 over 1, pi over 2 times 1 over 2. We end up with pi over 4. Now, sometimes, so pi over 4 would be our answer here. Obviously, sine is not 1 at pi over 4, but think about what happens if you plug it back in to check. So if we're checking this, we can do sine of 2 times pi over 4 minus 1 is supposed to equal 0. So 2, that's like 2 over 1 times pi over 4, that ends up being sine of pi over 2, which is 1, which does equal 0, so we can check that it works. So when we got that 2 there in that parentheses, we are going to get not the number we get when we look at the unit circle, but we've got to divide it by 2. Now, sometimes, whenever we have this happening, there might be things outside of principal values that actually do still work. Because basically we took half of this, right? So if we had another value, we would have to take half of it as well. So, for example, if 3 pi over 4 was an answer, which it's not, but if it was, and I took half of it, half of 3 pi over 4 would be 3 pi, that wasn't a great example, it would be 3 pi over 8, which would not be on the unit circle, but it would be over here. Or if I had, for example, if pi was an answer, which it's not, but if it was, and I had to take half of it, I'd get pi over 2, which is a principal value. Now, is there anywhere else on the unit circle that sine equals 1? There is not, right? I mean, I could do like 5 pi over 2. I could go all the way around the whole entire rotation and get 5 pi over 2. But there's nothing on this unit circle that's going to work. So in this case, it's not going to be the case, but we're going to see in a minute that it does happen sometimes. All right, so questions on 1. All right, and so for example 2, I'm going to ask myself, can I solve for that tangent right there? Is it possible for me to solve for that tangent? I get the tangent by itself. Yes, I just got to move the square root of 3 over to the other side. So, tangent of 2x is going to equal the square root of 3. Oh, and we all hate these tangents, or at least I do. I do not like them, because tangent's not on the unit circle, so it makes us work harder whenever we have tangent. But we're thinking about, where does tangent equal the square root of 3? So, it's either pi over 6 or pi over 4. I can't remember. Can somebody remember? Not pi over 4. Pi over 6 or pi over 3? Anybody remember which one it was? I think it's pi over 3. Is it pi over 3? I think it is. But I'm going to double check over here just by doing sine over cosine, so square root of 3 over 2 over 1/2. Because those are my values here at pi over 3. And that is square root of 3 over 2 times 2 over 1. 2's cancel, square root of 3. So, it is pi over 3. So, I don't want to say x equals pi over 3. I've got to say 2x equals pi over 3. Okay, and so whenever I do this, I'm going to have to divide both sides by 2. Since this is a fraction, are you guys okay with this? If I just multiply by 1/2 on both sides, then I don't have to flip the second and multiply. It'll cancel here. I will get x equals pi over 6. So there's one of my answers. Now notice I said one of my answers. That's the only principal value where this happens, right? Because down here at 5 pi over 3, I would get a negative because I've got negative square root of 3 over 2 times and 1/2. So this would not be a value. Where else would, on the unit circle, don't worry about principal values. Where else would tangent equal square root of 3? Right, so at 4 pi over 3, I would be doing negative square root of 3 over 2 over negative 1/2. Negative over negative would give me positive. I would still get square root of 3 right here. All right. So if I had 2x equals 4 pi over 3, that is not a principal value. But if I multiply both sides by 1/2, I need to check to see if it is a principal value. So that would be 2 pi. You get 4 pi over 6, which is 2 pi over 3. Is that a principal value for tangent? Raven, which quadrants were principal values for tangent? Same sign, 1 and 4. So is 2 pi over 3 in the first or fourth quadrant? No. So that's not actually an answer. What else could I call 4 pi over 3? What else could I call it? What if I use negative radians for it? So if I use, oh, sorry about that. If I used negative radians for 4 pi over 3, Paul, what would that be? So if instead of going around in the counterclockwise direction, what if I started here and went backwards? Okay. So if you can look at, like, up here, it would be this distance if I was going this way, right? It would be this distance here. So it would be negative 2 pi over 3. Or the other thing you can do, 4 pi over 3, you could subtract 2 pi from it, which would be 4 pi over 3 minus 6 pi over 3, which would give you negative 2 pi over 3. So if I do 2x equals negative 2 pi over 3, and I multiply both sides by 1/2, I will get negative 2 pi over 6, which is negative pi over 3. Now, is negative pi over 3 a principal value for tangent? Where would negative pi over 3 be? What value that we see on the unit circle would it be? It's 5 pi over 3. Is that a principal value for tangent? Is it in the first or fourth quadrant? Yes. So this is another answer. So when we're doing these problems, and we're having to divide by 2, we're going to need to look outside of just the first and fourth quadrant, because if we have an answer that will work, and when we take half of it, it ends up being a principal value, it is still one of our answers. Okay, questions on number 2? All right, let's look at 3. So for 3, I got cosine tangent minus 2 cosine squared x equals negative 1. This one is not one that has the 2x with it, right? So we're not going to do what we were doing on that last. What do you guys think we should do? Any ideas? Tangent is sine over cosine. So we're going to have cosine x times sine x over cosine x minus 2 cosine squared x equals negative 1. And when we do that, now our cosines can cancel. I've got sine x minus 2 cosine squared x equals negative 1. All right, I need some ideas now. Okay, Zach Darnell, any ideas on what we could do? Are we okay canceling? Changing to tangent and canceling? Okay, we're right there. All right, so what do you think, Matthew? We can, but it's really not going to get us very far. Because we're going to have a hard time doing anything with this when we have sines and cosines. What do you think, Wesley? Almost. This 2 right here is going to stay right here, and then we'll have a 1 minus sine squared. So don't put the 2 over here with the sine. Just replace this part right here with 1 minus sine squared x. Yes? You can't, because if you do, it is going to, like you have to divide the sine x by 2 and the negative 1/2 by 2, so you would end up with like sine x over 2 here, which would be hard to work with. What is really best here is just for us to distribute our 2. So we got sine x minus 2 plus 2 sine squared x equals negative 1. Now, I've got a sine squared and a sine. So this is like having a quadratic. It's something with an x squared, right? Except for instead of an x, we have a sine squared. So this is something that we're going to have to factor more than likely. So we want to move everything to one side. So I would add this 1 over here. And we are going to get 2 sine squared x plus sine x minus 1 equals 0. So when you see that you've got a sine squared and a sine, or maybe it might be a cosine squared and a cosine, move everything to one side and see if you can factor it. So, let's see, Matthew Bashir's, how is this going to factor? Good. Let's test it and see if it works. So when you have a number in front of your x squared, it's a little tougher. So if we check this to multiply it back, we get 2 sine squared x minus 2 sine x plus 1 sine x minus 1. Does that work? It's negative 2 and positive 1 is going to give us a negative sine x. So what should we do instead? Minus 1 plus 1. We just need to switch those signs, so it's not a difficult fix here. Sometimes you got to kind of look at it a little bit to see what you're going to have there. Maybe test it and change it. And so this is going to give us 2 sine x minus 1 equals 0, and this is sine x plus 1 equals 0. So 2 sine x equals 1. Sine x equals 1/2. And over here we'll get sine x equals negative 1. This one asks us to look at the whole unit circle. Zach Hawkins, where does sine x equal 1/2? And anywhere else? Five pi over 6. And Ethan, where does sine equal negative 1? Good, so that is our other answer. Okay, so questions there on number 3. All right, let's look at 4. 4's got a fraction in it. And not only does 4 have a fraction in it, there's no like tangents or cosecants or something where we could change it back. Everything's already sines and cosines. But remember, with equations, when it says solve, you can move stuff from side to side. So I could put this over 1, and I could cross multiply, which is just going to give me 1 when I cross multiply in this direction. And over here, I'm going to have cosine x plus sine x, make sure you put parentheses around it, times cosine x minus sine x. And so this is a difference of squares. If you need to, you can distribute everything here. But those middle terms are going to cancel. You're going to get a positive sine x cosine x and a negative sine x cosine x. So I'm just going to get cosine squared x minus sine squared x. So there's some different ways you could go with this sort of reasoning through. But I want to introduce you to using these up here. So at this point, I've got, or should I? No, there's a better way. We could use cosine squared minus sine squared right here and change this to cosine 2 theta. It's a possibility and can be done that way. But I feel like we're going to be a little bit weak on this, and really our probably best bet, when we have sines and cosines, what can we do? Yes, that's what I'm looking for. I think that's going to come more natural to us because we've done that a lot more. So if we do 1 minus sine squared x minus sine squared x, we are going to get 1 equals 1 minus 2 sine squared x. And now we only have one trig expression, so we could just subtract this 1 here. We will get 0 equals negative 2 sine squared x. We can divide by negative 2. So 0 equals sine square x. And we can square root both sides. Normally, we would put a plus or minus sign whenever we do that. But because this is 0, that doesn't make sense to do in this case. So we're just going to have sine x equals 0. And Sarita, where does sine x equal 0? Good. And where else? At pi. So 0 and pi would be our 2 answers. Questions? All right, so example 5 starts to become where we can no longer avoid using those identities that I had up at the top of the paper, because in this case I can't ask myself where does cosine equal 1 minus 3 sine x unless you have a brilliant mind that can plug all these unit circle values in and see really quickly where cosine is going to equal 1 minus 3 sine x, which I'm not even close to having. That's not going to get you anywhere, right? So in this case, we're going to have to use the identity for cosine of 2 theta, which is cosine squared theta minus sine squared theta. So we can take this right here and replace it with cosine squared theta minus sine squared theta. Okay, any ideas on what we should do from here? Perfect, because we can't do anything with a sine and a cosine there, and we know we got just a single sign that we can't change. So we are going to do 1 minus sine squared theta minus sine squared theta, which is going to give me 1 minus 2 sine squared theta. What comes next? What do you think, though? Probably so, yes. This is something I will not count off for you if you also do this on the test. But yes, I should be using x's everywhere. But I just switch back and forth. Yes. Yes. But I'm going to say this, like, at this point, our strategy is going to have to be to factor something, because we have a sine squared and a sine. So I would go ahead while we're at it and move everything to one side. So I would subtract this one here and add the 2 sine squared x. You could move just the 1, but then you're eventually going to have to move everything anyway. So that's going to give us 2 sine squared x minus 3 sine x minus 2 equals 0. And what do we have to do at this point? Factor. So pretend like that sine is just an x. We're going to have 2 sine x and sine x. And I think I can do a minus 2 here and a plus 1 here. And if you check, 2 times 2 sine x times negative 2 is going to give you negative 4. And then 1 times sine will give you 1. Negative 4 and 1 is going to give you that negative 3 that you need. Alright, so at this point we just need to set each one equal to 0. 2 sine x plus 1 equals 0, and sine x minus 2 equals 0. So over here you'll end up with sine x equals negative 1/2. And here sine x equals 2. Does sine x ever equal 2? No, so we just don't get any answers from that part. Josie, where does sine x equal negative 1/2? Perfect. So we'll say negative pi over 6 for our answer there. This one only asks for principal values, so we'll just give that answer. Why would we not use anything else? So since this is principal values and we're dealing with sine, anything in that fourth quadrant we are going to use negative negative radians for. And so since right here, just messed everything up. There we go. So right here, we're really 11 pi over 6 is where our sine is negative 1/2, but that's not between negative pi over 2 and pi over 2, so we would use negative pi over 6. Okay, questions? All right, we're going to run into the same thing on number 6. I can't solve this with this cosine 2x right here. So we're going to do just like we did on the last problem. We're going to change it to cosine squared x minus sine squared x, and that's going to equal 2 minus sine squared x. It's cosine minus sine, right? Sometimes I forget it. Yeah, cosine minus sine. All right, any ideas of what we should do here? What? We can. That'll work. In this particular case, though, what happens when I move my sine squared? So it would just cancel. That's just made me wonder if it's right. Uh-huh.
So you wouldn't change cosine squared x to 1 minus sine squared x?
You could. Let's go down this route in a second and check the other way as well and see if we get the same answer. Because I'm getting a little, when I square root both sides here, I get cosine x equals plus or minus the square root of 2. Does cosine x ever equal plus or minus square root of 2? It does not. So I don't get any answers from that, which would mean this would be no solution. Let's try what Bo said, though, just to make sure we also get no solution there. If I change that to 1 minus sine squared x, so I'm taking this cosine and changing it 1 minus sine squared, minus sine squared x equals 2 minus sine squared x. So I get 1 minus 2 sine squared x equals 2 minus sine squared x. In this case, since both of my sines are squared, I could like add my sine squared x here. Yeah, it's going to work. Or not work, I should say. So I got 1 equals 2 plus sine squared x. If I subtract my 2 here, I got negative 1 equals sine squared x. And then I got to square root both sides. And can we take the square root of a negative? No. So that tells you also no solution. So that's just an alternate way of solving right there, but it would work. On verifying, they should always be true, right? You're not going to have something that doesn't work out. But on solving, it is possible to get no solution. It shouldn't happen a lot, but it is possible. All right, any questions so far? We just got one more left to do, even though I might need to do in fact, I'm not going to do example 7. Yes? Where did this go? Yeah, okay. All right. Okay, I'm going to skip 7 because I think you guys can do 7 on your own maybe now. And I want to skip down here and do a couple others. I want to do 4 and 5 because I need to rearrange these notes. Because we haven't done anywhere we use the sine 2x yet. We need to do one of those. So let's do number 4 first. So we got sine squared of 2x minus 2 sine of 2x equals negative 1. So this one's a little bit different because both of our sines have a 2x, right? So we're actually going to move everything to one side here. Sine squared 2x minus 2 sine 2x plus 1 would equal 0. And I can factor this. I don't actually have to change it because they're both 2x's. So I can get sine of 2x and sine of 2x here. And if I make both of these a minus 1, then it'll factor correctly. So then I've got sine of 2x minus 1 equals 0. So sine of 2x equals 1. And I don't have to write that twice because both of my factors are the same here. So this is going to be like that first problem that I did. I'm going to say, where does sine equal 1? And where does sine equal 1? Pi, not pi, over 2. Pi over 2. So instead of saying x equals pi over 2, because I got a 2x in here, I've got to say 2x equals pi over 2. And then to solve that, I'd multiply both sides by 1/2. And so x would equal pi over 4. Now, here's a trick with this. Okay? They asked us to look at the whole unit circle. Is there anywhere else on the unit circle that sine equals 1? It's only right here, because down here it equals -1, right? So that's the only place on the unit circle. But in general, whenever you've got a 2x right here, you need to look at twice the area that you normally would look at. Okay? So, pi over 2 is the answer. But what if I do pi over 2 plus 2 pi? Right? That's going to be pi over 2 plus 4 pi over 2, which will give me 5 pi over 2. So 5 pi over 2 is not on the unit circle, but it's equal to pi over 2. Right? They're coterminal angles. However, if I do 2x equals 5 pi over 2, and I multiply both sides by 1/2, x is going to equal 5 pi over 4. Is 5 pi over 4 on the unit circle? Yes, so it is an answer. I could do this again. I could add 2 pi again, just to check to see if something else works. I'd get 9 pi over 4. So if I did 2x equals 9 pi over 4, if I multiply by 1/2 on both sides, I'm sorry, that shouldn't be 4, it should be 2. X would equal 9 pi over 4. Is 9 pi over 4 on the unit circle? No, so that was too big. In general, though, it's going to be twice whatever area you would normally look at if you've got this 2x right here. So instead of just looking at the unit circle from 0 to 2 pi, we're going to look 0 to 4 pi, right? If we're talking about principal values, instead of just looking like from negative pi over 2 to pi over 2, we're going to look from negative pi to pi. So twice the area. Or if it was like a 3x, it'd be 3 times the area. Or 4x would be 4 times the area that we normally look at. These will be partial credit. So like if you get pi over 4 and you forget to look for 5 pi over 4, you can still get partial credit on it. Because what I normally see is that there's a lot of students that we forget to look for that second answer there. Okay, questions? All right, let's do 5, and then I'm going to let you guys work, and hopefully you can get most of it done before we go. So sine 2x times sine equals cosine x. I can't do anything with a sine 2x and the sine and the cosine. So what I'm going to have to do is go back up here to the top, and I know that sine 2 theta should equal sine 2 sine theta cosine theta. So I'm going to use that. So I'm going to change sine 2 theta to sine 2x to sine 2 sine x cosine x times sine x, and that should equal cosine x. And then all this is multiplied. I can put those two signs right there together and write it as 2 sine squared x cosine x equals cosine x. Yes. You can. What will you get whenever you do that? No. Which is why I asked you and didn't just say what it was here. So, this is 2 sine squared x times cosine x. That means that's like having a 2x squared y, right? So it's two variables there, so they're not common terms. So what would we have instead? Nope. We're going to have to just write it 2 sine squared x cosine x minus cosine x. I know that looks worse than it did to begin with, but it's still the right thing to do. Okay? If you divide it off, you will get 1, and you will lose an answer if you do that. So, in general, you never want to divide both sides by a trig function and have it cancel out, right? The only time that you can have something cancel out like that, where you're canceling trig functions, was it on here? Was like on number 3, where we had to change tangent to sine over cosine. So if you're doing something like that and it cancels on one side, that's okay. But if you find yourself dividing both sides by something where it cancels out, then you probably should not do that, because you'll still get one of the right answers, but you'll miss an answer if you do that. So instead, we can factor out a cosine x, and we get 2 sine squared x minus 1. And now that this is factored, and because it's equal to 0, we can say cosine x equals 0, and 2 sine squared x minus 1 equals 0. And cosine x is really straightforward. Cosine equals 0 at pi over 2. So pi over 2 is one of our answers. That's the answer you would have lost if you had divided both sides by cosine, because it wouldn't be there. And then over here, we'll have 2 sine squared x equals 1. We'll divide by 2. Sine squared x will equal 1/2. What do we have to do now? Square root. What's that going to give me? How do we square root a fraction? Square root the top, square root the bottom. So top's going to be 1. Can't do the square root of 2, so I'm just going to have to leave it square root of 2 there, right? That's not on the unit circle. What can we do, Major? Very good. So we get plus or minus square root of 2 over 2, and that is on the unit circle, right? So, Major, where does sine equal positive or negative square root of 2 over 2? Okay, so this is sine, so we're looking at principal value, so we'll be looking just at the first and fourth quadrant is all we're going to look at here. So we're looking, sine is our y-coordinate, so we're looking for where that y-coordinate equals either positive square root of 2 over 2 or negative square root of 2. And Matthew, where does that happen? Perfect. Pi over 4 is right here because we can see our y-coordinate is square root of 2 over 2, and so we get the radians with it. And then down here, we see we have negative square root of 2 over 2. But because they told us to do principal values here, we can't say 7 pi over 4. We have to do negative pi over 4, like Matthew said. So we end up with 3 answers for this one. Yes? Yes, that's fine. Yeah, just make sure when you do that you also square root 2, because if you don't do that, then you'll mess up. But yeah, that's fine. Okay, any questions? I'm sure you'll have some later, but we're good for now. So you got about 15 minutes. The homework is to finish this up. Do as many as you can. Yes. Yeah, do example 7 for me. We'll let that replace the 2 that we did together. So do example 7 and then finish up all the ones that say their homework. And I'm also going to pass out the review in case you want to start looking at it over the weekend, but it is not going to be due until Tuesday. So you don't have to work on it. We will work on